Hello, this is Mr. Buffington from Simplify Academy, and today we are looking at prime factorization. That's a fancy long word. I'm going to show you what it is, how to do it, and that it's actually not that bad. We are going to talk about factors, we're going to talk about prime factors, and we're going to look at factor trees. If you've done any of these things before, then this lesson can be a bit of a review. It's really pretty straightforward once we get into it. Factors are numbers that multiply together to give you a product. We talked about that in our previous lesson. I gave you this example that 2 times 6 equals 12. That 2 and 6 are factors of 12. But we could also say 2 times 2 times 3 is 12. Therefore, 2, 2, and 3 are factors of 12. You don't always have to have a factor pair. And although we did list factor pairs in our previous lesson, what we're doing today is going to be a little bit different, but kind of along the same lines. What we're going to be doing is looking at prime factors. Prime factors are the prime numbers that multiply together to give you a number. And here's an example. If I asked for the prime factors of 20, that's the prime numbers that will multiply together to give me 20. 2 times 2 times 5 is 20. And just a quick review on what a prime number is. A prime number has only the factors of 1 and itself. So for example, 2 has the factors of 2 and 1. That's it. 1 times 2 is 2. That's the only factor pair for the number 2. Same with the number 5. 1 times 5 is 5. 1 and 5 are the only factors of 5. Here is the tool that I am going to use for finding prime factors. It's called a factor tree. And with a factor tree, you basically take the number you're starting with, and in this case it's 20, and you list two factors of that number, two numbers that multiply together to give you 20. You can use any factors of 20 except for 1 times 20. That just won't be really helpful in this case. So what you're going to do is then list the factors. In this case, I'll pick 4 times 5. 5 is a prime number. 4 is not a prime number, so we keep going with 4. 4 is 2 times 2, and those are both prime numbers. And that's the way factor trees work. What you could also do is start off with 10 times 2. And it will work out. 2 is a prime number. 10 is not a prime number. It's a composite number. So we have to find the factors of 10. Well, 2 times 5 is 10, and those are both prime numbers. Notice with both lists of numbers that are circled in green, it's 2 times 2 times 5. It doesn't matter which factors you start out with, you'll always end up with the same prime numbers if you do this properly. All right, so here's our assignment. Find the prime factors of 24. All right. Pause the recording. Try it out. You can use a factor tree, or if there's another way you find to do it, that's fine too. But try it out and list the prime factors of 24, the prime numbers that multiply together to give you 24. Here's what I did. I listed the factors of 4 times 6. Both of these are composite numbers. 4 is 2 times 2, and 6 is 2 times 3, or 3 times 2. So the prime factors of 24 are 2, 2, 2, and 3. In other words, 2 times 2 times 2 times 3 is equal to 24. Notice in blue I've used the big word that you saw at the beginning, prime factorization. Prime factorization is the list of numbers that are multiplied together to give you 24. Typically, when you find the prime factorization, you list the numbers from least to greatest. So we wouldn't say 2 times 3 times 2 times 2. You put all the 2's together, all the 3's together, and you go in order from least to greatest. So now we're going to use that word. What is the prime factorization of 100? Go ahead and solve that question. What is the prime factorization of 100? Go. All right, here we are. I started out by saying 10 times 10. I know 10 and 10 are both composite numbers, but they're both factors of 100, so it was a good place to start. The factors of 10 are 2 times 5 and 2 times 5, or 5 times 2. Remember, when we're listing the prime factorization, I'm going to list them in order. So I would say 2 times 2 times 5 times 5 equals 100. Now, there is one other thing that you can do with prime factorization, and they will do in future grades. So I want to show this to you, but I will not expect you to remember it, and you don't need to remember this moving forward. But instead of writing it as 2 times 2 times 5 times 5, we could write it using exponents, where you write 2 squared times 5 squared. All right, and that is in the very final, like when this is a fine-tuned machine, that's the way you'll be writing it. But for now, we're mainly going to be writing it as products. The worksheets and quiz will all be written as products. You don't need to learn how to do the exponents. I just wanted to show you what it would look like with exponents. So that's not completely new when you hit it again in future grades. All right. What is the prime factorization of the number 3? Maybe this was confusing for you because 3 is a prime number. So you don't really do a prime factorization for the number 3. We wouldn't say 1 times 3. We just say 3. So the prime factorization of 3 is 3. It's a prime number, so we typically won't be finding prime factorization for that. Again, with prime factorization, you do not see the number 1 included, because you could say 1 times 1 times 1 times 1 times 1 times 1 times 3, and that's just silly. Besides, 1 is not counted as a prime number. It's sort of counted outside of that. So we're not considering 1 a prime number, so it's not part of prime factorization. Time for the next question. Try this one out, pause, and practice. What is the prime factorization of 144? Go! 144 is an interesting number because it has a ton of factors. It's got a lot. So maybe I don't know all of the factors of 144, but I know that it's an even number. So I'll try 2 times 72. And I know 72 is an even number because it ends with a 2, so maybe I'll do 2 times 36. And 36, well, that's an even number. That's 2 times 18. And 18, well, that's an even number. It's 2 times 9. And then, boom, we ran out of space. Uh-oh. Now, when you're writing it out on paper, running out of space isn't a problem. But just for our purposes, I think it's helpful for us to remember to keep it balanced. The more balanced it is, the less space it will take up. So for our purposes, we're going to try again and use some different factors at the beginning. Here we go. We're going to start with 144, and I'm going to use 12 and 12. 12 times 12 is 144, and watch how this takes up a lot less space. I can do 2 times 6 over here. I can do 3 times 4 over here. You don't have to use the same factor pairs for 12. Both of them have 1 prime factor, and then 4 is 2 times 2, 6 is 3 times 2. So I've got all my prime factors, and they fit in a nice small condensed space. Notice how that worked out a lot better. It kept the tree a lot more even when we used large factors. So I wanted to show you that as an example with using this number. Now what I'm going to do is list all of the factors in order, and again, this is why we would sometimes use exponents to try and keep it a little bit more simplified and condensed. Again, using exponents is not a requirement at this point, but I just want to show you what it would look like because it simplifies things. And this is Simplify Academy. Let's talk about prime factorization of 91. Go ahead and try that one out. Go. Well, prime factorization of 91. It doesn't have a lot of the typical prime factors you would think of, like 2 and 3 and 5, but it does have 7 times 13. And 7 is a prime number, and 13 is a prime number. So this one's actually a kind of strange number that most likely you won't see very often, but the prime factorization of 91 is 7 times 13. It's kind of a weird one, but definitely good to keep an eye out for ones that have different factors like that. All right, what's the prime factorization of 420? Try that one out. Remember to try and keep this one balanced because we definitely have lots of factors when we're getting larger numbers like this. Okay, try it out. Welcome back. I picked 20 times 21 as my prime factor, or as my initial factors. 20 is 5 times 4. 5 is a prime number. 21 is 3 times 7, and that they're both prime numbers. And 4 is 2 times 2. Now you could have started with 10 times 42, and it would have worked out, and you would have gotten all the same prime factors. But these are the numbers I chose. Either way, you'll end up with this as your prime factorization. If you write it using exponents, it doesn't really condense it that much. It's still 2 times 2 times 3 times 5 times 7. Lots of different prime factors with this one. Couple of things to remember. Factor trees are great tools for finding prime factorization. We're looking for prime factors. Prime numbers are numbers that are divisible only by 1 and themselves, and they do not include the number 1. And prime factorization is just the fancy word for all of the prime factors multiplied together to give you your final product. I hope that lesson was helpful for you. Have a wonderful day.